Hello everyone, in this video we are going to learn one of the very important concepts of solution, that is colligative properties. What do you mean by colligative properties? Okay, the properties which depend upon the number of moles of solute particle, not on the nature of it. Such properties are called as colligative properties. So just write the definition. The properties which depends upon the number of solute particles, not on nature of it, is or are called as colligative properties. So there are four colligative properties actually. Okay, examples. Okay, there are four colligative properties. First one is what? Relative lowering of vapor pressure. Relative lowering of vapor pressure. This is the first one. Second one is what? Elevation in boiling point. Elevation in boiling point. We are representing as delta TB also. Third one is what? Depression in freezing point. Depression in freezing point. We are representing this as delta TF. Okay. And fourth one is what? Osmotic pressure. Osmotic pressure. That is what? Pi. Represented as pi. So we learn one by one all the colligative properties. First one, relative lowering of vapor pressure. Vapor pressure. Okay, try to understand. Consider a solvent. Okay, consider a beaker is there. In this beaker, pure solvent is there. Let's take water is there. Okay, it is at some temperature. So we'll see the vapor will be there right now. Vapor will be there of solvent if you heat that solvent. So here it will exert a pressure over the solvent that we are naming as P1 degree. What is P1 degree? Vapor pressure of pure solvent. Okay, some terms are there, you should remember. P1 degree is what? Vapor pressure of pure solvent. In this solvent, now we are adding some non-volatile solute. Non-volatile solute like glucose. So if once you mix a non-volatile solute, okay, so non-volatile solute, what will happen? It will not convert into vapor. Okay, so now it is a solution, right? Solute plus solvent is a solution. So due to this, if you heat at the same temperature, so there will be lowering in vapor pressure. Yes or no? So we can see after adding if you heat at the same temperature, now in this case what happens, after mixing the non-volatile solute, there has been lowering in vapor pressure. Okay, vapor pressure will be decreased. So now because in this solute is also there and solvent is also there. So when it is at some temperature, okay, now so there is this is P1 only. P1 is what? P1 is nothing but vapor pressure of solution because solute is also mixed, right now. So here solute from where the solute is there, vapor will not generate. Yes or no? Here P1 degree is more than P1 right now. So what has happened upon mixing the non-volatile solute? There is a lowering in vapor pressure. So we can write P1 degree minus P1. What is P1 degree minus P1? So P1 degree minus P1 is what? This is lowering in vapor pressure. This term is what? Lowering in vapor pressure. Vapor pressure. Now lowering in vapor pressure by original vapor pressure is called as relative lowering of vapor pressure. P1 degree minus P1 upon P1 degree. This is called as what? Relative lowering of vapor pressure. Lowering of vapor pressure. Vp means vapor pressure. Am I clear? See, this is depending upon the solute which we are adding right now. So can we write P1 degree minus P1 by P1 degree is equal to what? Mole fraction of solute particle. How do you find the mole fraction of solute particle? Number of moles of 2 by number of moles of 1 plus number of moles of 2. Okay, if the solution is dilute, okay, for dilute solution, okay, the solvent is far more than solute right now. So number of moles of 1 is far more than number of moles of 2. Okay, that is solvent is far more. So can we write N1 plus N2 is equal to approximately equal to N1 right now? So if you substitute P1 degree minus P1 upon P1 degree is equal to N2 by N1. What is N2? W2 by M2. Okay, now weight of solute by molecular weight of solute. What is N1? W1 by M1. So finally we can write that relative lowering of vapor pressure P1 degree minus P1 by P1 degree. Okay, so you can see here M2 will come down, M1 will go up right now. So W2 by W1 into M1 by M2. Okay, so we can write W2 by M2 into W1 by M1. So this is the formula to find the vapor relative lowering of vapor pressure. Generally they will ask in the numerical M2, molecular weight of solute. Am I clear? Next concept, so we have a elevation in boiling point. Elevation in boiling point. Okay, try to understand what do you mean by boiling point. Boiling point is a temperature at which the vapor pressure of liquid is equal to that of the gas. Am I clear? So try to understand, suppose a pure solvent we are taking. Okay, let's take water is there. Okay, what is the boiling point of water? 100 degrees Celsius. So at some temperature, that is T degree B. T degree B is what? A boiling point of water. So when the vapor pressure of liquid is equal to that of the gas, then it is boiling right now. So we are writing term T degree B. What is T degree B? Boiling point of pure solvent. Boiling point of pure solvent. Now try to understand, once you mix a non-volatile solute, okay, now once you mix a non-volatile solute to this, what will happen? Try to understand. Okay, I'm taking the other one. If you add non-volatile solute, in this case, non-volatile solute like glucose you add. Okay, non-volatile solute means again it will not convert into vapor right now. It will occupy the surface of the water or solvent. So from wherever you have added wherever it is available, from there vapor is not generated. Okay, so here vapor pressure will be less, decreased right now. Now I want to boil, okay, the solution, because this is solution only right now, solute is mixed. So to get this much vapor pressure, we have to give this T degree B plus you have to give some more temperature. So T degree B plus delta TB, this is nothing but TB, that is at boiling point of solution. What is TB here? TB is what? A boiling point of solution. Okay, how we can write TB? TB is nothing but T degree B, we have to give that much temperature plus some more temperature we have to give to get this much of vapor, so that it will boil. Yes or no? So T degree B plus delta TB. Yes or no? So we can write delta TB is nothing but a TB minus T degree B. Remember this one, TB minus T degree B. As it is depending upon the solute which we are adding right now, so it is a colligative property. So can we write delta TB is directly proportional to the molality? Okay, what is this? Molality. To measure the concentration of a solute, best is what? Molality. Okay, so we can write delta TB is directly proportional to the molality. Once you remove the proportionality, you have to put a constant, that is Kb into molality. Molality is what? Weight of solute by molecular weight of solute into mass of solvent in gram into 1000 we have to do. So this is the formula to find the delta Tb. Most of the cases in the numerical, they will ask you to find the molecular weight of solute. Am I clear? Here Kb is called as ebullioscopic constant, okay, are also called as boiling point elevation constant. Boiling point elevation constant. Am I clear? Okay, so M2, we can write the formula for M2 also. M2 is nothing but Kb into W2 into 1000 upon delta Tb into W1 in gram. Directly you can use this formula to find the M2 also. Am I clear? Or best you remember this formula only. Next, third colligative property is what? Depression in freezing point. Depression in freezing point. What do you mean by freezing point? It is a temperature at which the vapor pressure of solid is equal to liquid, or liquid vapor pressure is equal to the solid vapor pressure. Yes or no? So consider a solvent. Consider a solvent is there which is freezing at a T degree F. Okay, freezing point. First you remember what is freezing point? Whenever liquid changes to solid at a particular temperature, that is at freezing point. Yes or no? Getting that? So suppose okay, any solvent is freezing at a T degree F temperature. T degree F temperature. What is T degree F? T degree F is nothing but a freezing point of pure solvent. Freezing point of pure solvent. Pure solvent. Okay, now once you add non-volatile solute to this, so vapor pressure will decrease, right? Now vapor pressure, there will be lowering in vapor pressure. Now as the freezing is reverse of boiling, right? Now if you want to freeze okay, this solution which contains non-volatile solute, so you can see the red color, non-volatile solute will be occupying, from there vapor will be less, okay, there will be lowering in vapor pressure. So now if you want to freeze, here vapor pressure is more, right now. So as the freezing is reverse of boiling, now if you want to freeze, so you have to give this temperature minus delta Tf. Okay, this is nothing but together they are called as freezing point of solution. What is Tf? Tf is nothing but a freezing point of solution. Okay, which is less than the freezing point of pure solvent. Yes or no? So Tf is actually nothing but a T degree F minus delta Tf. This is what lowering in freezing point. So if you move left hand side, this you move to right hand side. So we can write delta Tf is nothing but a T degree F minus Tf. Freezing point of pure solvent minus freezing point of solution. Am I clear? Now the depression in freezing point delta Tf, it is depending upon the solute which we are adding. So it is a colligative property. So can we write it is directly proportional to the molality, or we can write a delta Tf is equal to Kf into molality. What is molality? Weight of solute by molecular weight of solute into W1 in gram is there, means you have to multiply by 1000. Am I clear? So in this case, okay, delta Tf is what? Kf into molality, that is W2 by M2 into 1000 by W1 in gram. Here Kf is called as what? Cryoscopic constant. Cryoscopic constant. Okay, are also called as molar depression constant. Molar depression constant. It is also called as freezing point depression constant. Freezing point depression constant. Am I clear? So here also in most of the cases they will ask you M2, other things will be given. The last colligative property is what? Osmotic pressure. Osmotic pressure. So to understand osmotic pressure first, you should know osmosis. What is osmosis? It is a process of movement of solvent particle from the region of its higher concentration to the region of its lower concentration. So I am just making one arrangement. Okay, So this is a container. Okay, here partition is there, which is separated by semi permeable membrane. Okay, so semi permeable membrane is required okay, for the osmosis. This is SPM. SPM is what? Semi permeable membrane. Permeable membrane. So in this container we have kept a dilute solution. What is a dilute solution? And in this there is a concentrated solution. Okay, what is this? In this we have a concentrated solution. So once these two solutions are separated with the help of semi-permeable membrane, what will happen? The solvent from the dilute solution will move to the concentrated solution. This process of movement of solvent particle from the region of its higher concentration to the region of its lower concentration is called as osmosis. Okay, if you connect this one with the help of piston, okay, suppose it is coming inside with 5 atm pressure. If with the help of piston, if you exert 5 atm, what will happen? It will stop. The movement of solvent will stop. That pressure which is applied to stop the osmosis is called as osmotic pressure. It is represented as pi. Okay, so we can derive this one with the help of ideal gas equation also. In case of ideal gas equation, we have learned PV is equal to nRT. This is what ideal gas equation. Ideal gas equation. In case of a liquid solution, this P, that is pressure, is replaced with a pi, that is osmotic pressure. Pi V is equal to nRT can be write, or pi we can write as N by V RT. Number of moles by volume is what? Concentration of the solution. So can we write number of moles by volume is concentration CRT. Okay, or we can write one more from here only, number of moles of what? Solute. Okay, N by V RT is there na. So number of moles of solute actually. Okay na. So number of moles of solute, how we are finding? Weight of solute by molecular weight of solute into RT by V. Here R is what? Gas constant. T is the temperature in Kelvin we have to take. Okay, fine. Here pi is the osmotic pressure, W2 is the weight of solute, M2 is what? The molecular weight of solute. Is what? A weight of solute. M2 is what? A molecular weight of solute. Molecular weight of solute. Okay, V is what? A volume of solution. Okay, and R is gas constant. Okay, so these are all 4 colligative properties. I am going to summarize all the formulas once. First formula what we learnt? Relative lowering of vapor pressure. Okay, what is that? P1 degree minus P1 upon P1 degree. For dilute solution, how it is? W2 by M2 into numerator W1 by M1. Second one, what we learnt? Delta TB. What is delta TB? That is equal to Kb into molality. That is W2 by M2 into W1 in gram is there, means you have to multiply by 1000. Same third one is what? Depression in freezing point. Delta TF is what? Kf into molality, that is W2 by M2 into 1000 by W1 in gram. And fourth one, what we learnt? Pi is equal to either CRT or pi is equal to weight of solute by molecular weight of solute into RT by volume of solution in, if it is given in liter. Okay, fine. Or in milliliter means you have to again multiply by 1000. So one numerical is guaranteed in the board exam using this colligative properties. I hope you understood these colligative properties. Please like the videos and subscribe the channel. Thank you.